Alright, this morning I'd like to go over some examples of some of the forces problems based off of free body diagrams. I think this would help us quite a bit as we approach static problems on Newton's second law. So the whole idea behind some of the forces is very similar to what we did with the force table. It's just adding vectors together. Really, I'm just streamlining the process. So let's just make a random free body diagram. Let's say I have a force going down here at 80 newtons. Got a force coming off here at a 30-degree angle. Let's say it's like 50 newtons. And then we can have force coming up here. We'll base this off that axis. That's 20 degrees, and let's have this be 70 newtons. Doesn't really matter. The whole point of doing some of the forces is that we're trying to find the resultant vector. Once again, this is dot here in the middle represents some random object that's undergoing these forces. We want to know where does it go. That's what we want to know. So we're going to write out some of the forces in the x, some of the forces in the y. Remember, all that means is add up everything that's going in the x direction, add up everything that's going in the y direction. So when I look at this, if we were doing it force tables, I would write out here in my x and y for each of these. Okay, for each of these. And then I would add up all the x's together, then I'd add up all the y's together, and that's how we would do it if we're doing force tables. What we're going to do right now is pretty much just do part of that in our head. We're going to bypass listing these. Okay, so when we look here, some of the force in the x, this 80 going down, there is nothing going in the x direction. So that's just 0. We don't have that part. There is no x component to that vector. Here I look at this vector though. I have 50 newtons going at a 30-degree angle to the right. So that comes out as 50 cosine 30 for my x side. Remember, if you want to draw that into a triangle, okay, there's an x and y side. That x side length there is 50 cosine 30. If you're not sure where I'm getting that number, then I suggest you stop this video and go to my vector components video. That will explain that to you. Okay, so you do 50 cosine 30, and then here this guy's going to the left. Okay, so that's going to be a minus. Okay, but we have, if we draw this triangle, here's my x, here's my y, so this actually ends up being 70 sine 20. It's going to equal some number. Okay, let's look at our y real quick. Both of these vectors are going up, which are positive directions, so I get 50 sine 30 plus 70 cosine 20. But I'm going to minus 80 off because 80 is going down, and then I'm going to get that value. Now at this point, we plug it into our calculator. Once again, when we use our calculator here, we want to make sure we're in the correct mode. So we're going to click on mode. Okay, I've got right down here on this third line it says radians or degrees. I've got degrees highlighted, so I'm good to go. Okay, so here I'm just going to type in these values. Okay, so I got 50 cosine 30. Close that parenthesis, that's important. Minus 70 sine 20. 19.36. Then I'm going to do the same for my y. 50 sine 30 plus 70 cosine 20 minus 80. That gives you a value of 10.78. Both these are in newtons. So once we get that value here, all we do now is just draw a new vector. Okay, so we'll take something like this, Okay, we're going to draw it over. Now, I tend to do this on a new triangle. I try not to draw it right on this guy because it starts looking messy. But really, I'm starting at the origin, and I'm going to go over 19.36 and up 10.78. Okay, and so I'm going to go over 19.36, up 10.78. Okay, I'm looking for that side length now, and I'm looking for that angle. Remember, this right here is actually my dot on my free body diagram, that origin spot. I'm just taking this and I'm removing it from this upper diagram here. So, using Pythagoras theorem, 10.78 squared plus 10 or 19.36 squared, do the square root of both those. You're going to get a value of 22.16 newtons. Which makes sense. That's a good number. It's bigger than both of the side lengths, but not huge. Then we're going to look at that angle. We're going to use the inverse tangent there. I'm going to do opposite over adjacent, so that's 10.78 divided by 19.36. So the inverse tangent, 10.78 divided by that's going to give me an angle of 29.11 degrees. So that right there, that's an answer, and that's an answer. Now, some of our problems are we have free body diagram that looks like this, something where it's based on an angle. Okay, so let's say this is 30 degrees. Let's just make up a problem real quick. Let's go 80 newtons, 60 newtons. Let's say there's a tension force here at like 30 newtons. Let's say there's a little bit of something going there at 10 newtons. Okay. Now, if we were to do our sum of the forces right now on this, this is what you would end up getting. Okay. We could set it like that. That's our x and y axis, those dotted lines. And if we did this, we'd get something like this as our sum of the forces in the x. We get 30 cosine 30 degrees minus 60, oh, that's a 6, 60 sine 30 minus 10 cosine 30. Okay, that's what we would get, and that just looks messy. Or some of the force in the y doesn't look any better. You get 30 sine 30 plus 60 cosine 30 minus 10 sine 30, and then you have your 80 there. That's also going down. Okay, so neither one of those looks pretty, because that right there, that's my 30 degrees, here's 30 degrees, and here is 30 degrees. Okay, and so what we can do though is we can take this and you can rotate it 30 degrees so it looks like this example. That's 30 newtons. That's 60 newtons. That's 10 newtons. And then this one going down, which would be our gravity, that's 80 newtons. Then that inside angle there is that 30. If we do our sum of the forces in the x and y now, I'm going to get something like this. I'm going to get 30 newtons minus 10 newtons minus 80 sine 30. Then my sum of the forces in the y is 60 minus 80 cosine 30. You'll notice that right there looks a lot easier than this one up here. Now when you run numbers, okay, you're going to get just numbers here and here and here and here. What you need to look for, okay, if you do both these ways, when you draw out your resultant vector, whatever this is, when you draw out that length right here, that value needs to be the same for both scenarios. The only thing that's going to be different is the angle. Okay, the angle will be different. But the magnitude of the vector itself should be the same. The reason why the angle is different is because we've tilted this one 30 degrees. So the angle should have a difference of 30 degrees from each other if you were to do the two different scenarios side by side. All right. Hopefully that helps. If you have any questions, please feel free to email me or come in and ask questions. Let me know if there's anything I can do to help.